It can fail because of the load given by the code. It may not always be a structural engineer's mistake. It is a natural phenomena. This earthquake, wind, these are natural phenomena, and these are very probabilistic approach, and based on some statistical data. The code gives us a data which comes from the statistical background of the location. So if the statistics breaks, if there is a new record of seismic, wind, anything, any structure can fail. Failure modes: it can be a brittle failure, it can be a plastic deformation, it can be due to the buckling of the member, it can be resonance, it can be fatigue, it can be foundation settlement. Anything can happen. And the last one, as I have already mentioned this point, unserviceable. It can be because of the excessive deformation, acoustic deformation, anything. Now coming to the industrial structures. Industrial structures are different from normal a bunch of structures like we see here and there, the commercial structures, the residential structures, the bridges. Difference between industrial structure and other type of structure is mainly because of this interdisciplinary coordination. There are multiple disciplines involved in a industrial structure. Electrical team, there is a, mechanical team which handles the mechanical equipments. There is piping which is used for maybe some liquid flow, some other things. There will be cables, there will be CNI for lights. We need lights for the location also, for the plant also. So there will be multiple disciplines involved. Mainly there will be quality teams also, there will be HSE teams also, health and safety. They take care of those fire hazard zones. So there will be multiple teams, and to come to a conclusion to satisfy all the disciplines is the main problematic area of a industrial structure. Now we will see some example of an industrial structure, how all the departments are involved. So in this picture, you can see it is equipment substructure where some horizontal vessels are placed, horizontal exchangers are there, some pipes are moving, some cables are moving. So there are different things. The next picture you will see a pipe rack. A pipe rack is a very common structure in any of these. If you take any of the plants, it will be a common structure. So in a pipe rack, mainly there will be cables. There will be pipes moving through tiers, different tiers and different elevations. So that is the main purpose of this rack. And here also we have interdisciplinary coordination between the electrical team, who is the owner of these cables, the piping team, who is the owner of these pipes. So we need to get to a conclusion with an agreement with all the teams. Here you can see the structure, a concrete structure. There are many concrete structures in a plant. There are control buildings. Sometimes, because of the cost perspective, we have some open concrete building also. It depends, as I said, from project to project, from client to client, which material they want to use for which structure. Now the software depends. Before 20 years, 25 years, what we used to do, how do we used to, right now we have different kind of softwares to solve the indeterminacy, to solve bigger structures, to have the result in few seconds. Just click the model the structure instead SAP, whatever software you're using. There you model the structure, apply the load, have the end conditions, and you get the reactions. And if you design the structure, you will get whether the members are safe or those are unsafe. Before 20-25 years, there was not such kind of softwares available like we have in every company today. So what we did, we used to do 2D frame analysis. We used hand calculations, we used manual drawings. Many of you have seen that in our college we have done this manual drawings. Basically, that is for a basic concept generation to each one of us, so that we generate that concept within us. Otherwise, a concept is very much important for us, for any engineer, any individual. So, manual drawing, what we did in our college, that was a method used 25 years ago for original industrial structure designs. Problems? There were many problems involved. First of all, there was a great chance of human error. And many a times we do mistakes. We are humans, we are bound to do mistakes. So there is 100% a chance that we can do a mistake. And there will be no one who can judge that there is a mistake. It can happen that there will be no one. And this can cause several damages. Second thing, we were very conservative. We were doing a less economic because we didn't want that hazard that a structure can fail. So we wanted, we will give a very higher section that will not fail. So that's why the solutions given 25 years ago were less economic. The designs, the drawings, everything done at the time was very time consuming. Time was very important at that time. Right now, we just model it in STAD, SAP, we draw it in AutoCAD, we model it in Tekla. So there are several softwares available for structural engineering to structural design to fabrication. So it is very less time consuming. And the last and very important is the clashes or issues at site. As I have mentioned that there are multiple disciplines involved in a project, in an industrial structural project. So there will be many a chance that a bracing can clash with a pipe, a bracing can clash with a cable, a bracing can clash with a equipment. Anything can happen. And at 25 years back, at the time, we didn't had that ability to recognize that yes, there will be a clash. But now, yes, we can. How we can? The advantages. First of all, time has become very less for softwares. The efficiency has risen. We have higher efficiency, high economic design, less time consuming, less clash or issues at site, because we can see right now the models in 3D, where we can see how the plant will look like. We can have the same plant in our PCs, we can say have the same plant in our laptops. We can see, we can have that model, we can rotate in 3D and visualize that there will be no clash. Also, if there is a clash that we cannot see in our naked eye, we miss it. The structure will be, the software will be able to identify that. The software will tell you that there are 15 classes. If there is lesser headroom, as I've mentioned that in a 1.5-meter height room, you cannot move freely. So if there is something like that, that also the software will be able to highlight. Now, disadvantage or limit. First of all, cost of software. Yes, the cost of the software has risen, but also it is giving us economic design. So why not go for it? Second thing is very important, that is dependency on a machine. A machine does a work based on some predetermined codings. So the codes based on which the software is developed, it is generated by us only. So a software is not more than intelligent than a human being, because we made the software. Not only we have to so we have to use the software in our way. We cannot just blindly follow the software. We have to make our own judgments. We have to go with that. We can cross check whether the structure, anything in the structure is giving a wrong result or right result. One more thing, a structure is dependent on several inputs. If we are not giving, if we are missing on some of the inputs, the structure can give erroneous result. you we as a structural engineer have to judge whether it is giving us a right result or a wrong result as per our judgment. Then only we can, the software may not be erroneous. We have given some erroneous input, the the software is giving us erroneous results. So it depends how we are handling the software. Structural engineers role in digital era. Many of us fear that our software definitely reduces the human requirement, the engineer's requirement. It is not like that. We have to do the planning, we have to do the effective design. A structure cannot do it itself. We have to give the inputs. We have to choose whether it is a economic design, whether it is as per the judgment, whether it is constructible, that we have to judge. So we have to keep a balance between the software and the engine and the engineering. Since we need to identify the problems, we need to foresee. Reviewing while reviewing, say you have grown up, you have a experience of 5 years, 6 years, 7 years, blah blah blah. At that time you will have the opportunity to review a junior's calculation. It is not always that you will go through each and every word of his calculation report. You have to see the results, you have to judge in a point that whether the results are in the right direction or not. There will be some vendors data which will be used for your structural design. In those cases also you have to judge with the knowledge of your structural engineering. We need to force the problems. And last of all, these side queries. There will be many side queries, like we cannot do this connection, we cannot do that, alternate solution for this. For those cases a software cannot give the answer. So we are required, we as a structural engineer can solve those problems. And last of all, aiding other disciplines that is always there for industrial structures. We need to aid all the disciplines, and that's where these industrial structures are critical. What is the future of structural engineering? There will be, if you see in coming 10 years, there will be structures which will be connected. In today's world, we use STAT for structural engineering, TECLA for structural modeling, and for Navis work for integrated all discipline 3D model, where we can see clashes. So there are several softwares. For connection design also we have other softwares used. What we can see in 10, 15 years coming, there will be softwares like one software where you will give the inputs and the end product will be generated. You will not be required to give any kind of immediate input, like after designing the structure, you will give the input to the designer so that he can model it in Tekla. Then the Tekla model will go to the third party, where it will be imported into Navisworks. It will not be like that. In 10-15 years a day will come when you will see an integrated software where only one time input will be there and the end part will be there. And those will be more advanced softwares. Right now we do connection designs by some other software. In those cases it will be done within the software only. Software will be able to identify the connections. So there are many possibilities. From construction point of view, there will be modular structures. It has already begun. Basically, modular structure is a kind of structure, is a prefabricated structure that will be fabricated for most of the countries where the weather condition is extreme. Say for Canada, we have extreme weather conditions. In winter, we cannot have any kind of construction happening there. So what they do, they just they have just 6 months of window for construction, full construction. Otherwise their 1 year will be lapsed. So that's why what they do, they just fabricate the structure in a shop where they just fabricate whole structure, and a complete structure is being shipped or land transported to the site location at that time, so that the construction time becomes lesser, and it will be a very popular approach in many a cases in future also. One more thing is brownfield projects. Right now we are having many power plants, oil and gas petrochemical plants, and a day will come when you will see that it will be there will be no more requirement of a new power plant. So at that time, we will be dependent on these brownfield projects where we need to modify the existing structures. We need to strengthen the existing structures. Depending on the health condition, we have to study the health condition of the structure, how the structure, uh, whether the structure is fatigued, if there is corrosion, if the thickness of the member has reduced, like that. So everywhere, if you see, the engineer's role, whatever be the software dependency, whatever be the intelligence of the software, engineer's role cannot be replaced. Engineer has to be there to support all these things, to monitor whether the software is giving us right, whether it is proper for the project, whether it is constructible for health study, for everything. There will be machines, there will be softwares, but those cannot just replace the human effort, the engineer's efforts.